Okay, so I'm going to do a few more of these examples just to help a little bit because they can be a little confusing. Now, I will say for this particular assignment, what I'm looking for up here is a 15 out of 20. So I just usually grade this on a scale. So if you can get to a 15, I give you 100 on the assignment because I know some of these can be a little bit more difficult. So I'm going to look at some of the lower ones because I think in my last video I did some of the top ones, but that was a while ago, so I don't quite remember. So what we're doing in this top part is just identifying our metal and then our polyatomic ion and identifying the charges of them. So remember, when we name ionic compounds, the first part is the metal. So like when we look at the name, the first part will tell us what metal we're using. To get the charge of the metal, we have to use our periodic table, and we have to see, in this case, these are all going to be either group 1 or group 2 metals, so they're either all going to have a +1 or a +2 charge, depending on what we're looking at. And then for our polyatomics, we have to use our polyatomic chart, which I think I did link in the lesson, and it looks like this. Okay, so those charges tell us. So if we take a look, let's do lithium phosphate. So here we have our formula, which comes from the swap, drop, and chop. And then we have our lithium and our phosphate. So we know the charge of the phosphate is -3 because that comes from the table. So if we go to the table and we find our phosphate really quick, let's see where it is. Phosphate is right here. It's PO4 3-, so that's where the charges from these polyatomics are coming from. We're just grabbing them straight from the polyatomic ion chart. And then our lithium, we have to take a look at the periodic table and see what the charge will be. So I'm going to pull up my P table really quick. And I'm going to find lithium. So lithium is right here in group 1. And remember, the charges of our metals will always be how many valence electrons that they are donating. Again, the transition metals will need a Roman numeral. So like if we were dealing with any of the metals in our D block here, we would have to have a Roman numeral or look at the formula to see what the charge would be on those. But in this particular assignment, they're all either going to have a 1+ charge, so if they're in group 1, or a 2+ charge if they're in group 2. Because remember, group 1 gives away 1 electron and group 2 gives away 2 electrons, so they become positively charged. So lithium is in group 1, so he's going to have a 1+ charge. So we're going to do, we'll type in the name of the element, and then we'll give him a +1, okay? And then he'll turn green. I think there's one glitch on this assignment, like one of them is correct and it turns green, but then it says it's a 19 out of 20. So if that happens, again, I'm just looking for a 15 out of 20 when you submit this assignment, so you'll be okay. All right, so then let's take a look at number 6. Number 6 was a little bit tricky for some students. I was getting some questions on this one. So it says ammonium chloride. Now this is the one that is not polyatomic. So remember, when we're looking at ionic compounds, we can tell if it's a polyatomic ion by looking at the ending. So if it ends in ITE or ATE, that means we're going to have to use our chart. But if it ends in IDE, that's going to be my indication that this is just one single element. So chloride would be chlorine. Okay, so that's based on our ionic bonding naming rules. So since this ends in IDE and it's a chloride, I just have to figure out what the charge of chlorine is, and then we'll type this into our box. So Cl, not O3, it's just Cl. And then I had to figure out the charge. So since it's not a polyatomic, we'll just use our periodic table. So Cl is a halogen. It is a nonmetal. So it's going to become an anion because we know that our nonmetals on the right-hand side of the table are going to donate, or they're going to take electrons, our metals donate, our nonmetals take them on. So remember, the goal of the nonmetals is to fulfill their octet. So when we're figuring out the charge of our nonmetals, we don't find the charge by looking at the valence electrons. We find the charge by figuring out how many electrons they'll need to take to fulfill the octet. So for example, chlorine is a halogen. So he has 7 valence electrons because he's in group 17, so we dropped the 1. So chlorine has 7 valence electrons, so he needs 1 more in order to fulfill his octet. So this means that chlorine is going to take 1 electron. So that means his charge will be -1. So if we come back to the table, we just want to put his -1 charge in there as well. Okay. So same thing. So we have our formula done for cesium chlorate. So again, the chlorate's the polyatomic. I know it's polyatomic because it ends in ATE. This is the formula from the swap, drop, and chop. And then the metal is cesium. Okay, so we're going to do our cesium, and the representation for cesium is CS. And then we need to figure out what the charge of cesium is. So we're going to go to the table and figure out what his charge would be. Okay, so let's find cesium. Cesium's right here. It's atomic number 55, and cesium is in group 1. So he's going to donate 1 electron, which means he will have a 1+ charge. Okay, so for the metals, we are just taking a look to see what their charge will be, because they'll either donate 1 or 2, depending on if they're in groups 1 or 2. Again, this particular assignment right here does not have any transition metals, so all the charges on the metals are either going to be 1 or 2. Okay, so then if we take a look at, let's do this last one together, and then we'll take a look at some of the naming below. So now we're going to do our swap, drop, and chop. So the last part in this row, we're going to need to do our swap, drop, and chop to figure out our formulas. So here we have potassium sulfate. So our potassium has a charge of +1, and our sulfate has a charge of -2. So we're just going to do our swap, drop, and chop. So we've got a K +1, and we have an SO4 -2. So let's swap, drop, and chop our charges. And that would give us K2 and then SO4. Because remember, if there's a 1, we don't actually have to write it. So it would just be K2 SO4. So let's type this in. And the good thing about this assignment is that we don't have to worry about making them subscripts or superscripts. It just recognizes the number. Okay? All right, so for the first column, you're just identifying the metal. It will be the first word here. And then you're going to figure out the charge by looking at the periodic table. So if it's in group 1, it's going to be a 1+ charge. If it's in group 2, it's going to be a 2+ charge. The charges on the polyatomics, you just have to, if it ends in 8 or 8, we're looking at the polyatomic chart and it will tell you the charge. So if it's just a negative, that means it's -1, or then it'll tell you if it's 2- or 3-. And then I think that one example that we did was the only individual element. So if it ends in IDE, that means you do have to calculate it from the non-metal side. Okay? So let's take a look at some more of these on the bottom with the naming. Let's do a few of these before we wrap up. So again, with the naming rules for ionic bonds, you always name the metal first, and then you either if it's a polyatomic ion, you have to use the chart, or if it's a single element, you will write the name of the element and then change the ending to IDE. But with all of these, all the anions in this one are going to be polyatomic, so we're just going to use our polyatomic chart for every one. So let's do like maybe the last 4 here, okay? So my metal is Li, that's lithium, so I know my first part's going to be lithium. And then NO3, I just need to figure out what that is on my chart. So NO3 is right here. It's nitrate. So this is going to be lithium nitrate. Okay, so then let's do our next one. We have to first identify our metal. K is potassium. And then CO3 -2, I just have to find that on my polyatomic chart. Now, in this case where we're not given the formula, if you're just given, or you're not given the name, but you're given the formula, so we're given the anion, if you're trying to tell whether or not it's polyatomic, if it's got 2 capital letters, it's polyatomic, right? Because all of our elemental symbols are either 1 capital letter or 1 capital letter and a lowercase letter. So if you're trying to tell if something's polyatomic, if it's got 2 capital letters, that means it's polyatomic, and you're going to have to use your chart, okay? So CO3 is our next one. So we've got, let's see, where's CO3 at? Some of these are really tiny. Here it is, CO3 2-, there's our anion, and the name of that is carbonate. So I'm just gonna write carbonate and name it that way. So thankfully, the ionic naming rules are pretty easy. You just identify the metal, identify the polyatomic. In this case right here, this is another one students were having some trouble with. These are both polyatomic ions. So this one just happens to be a positive polyatomic ion. So we're just going to have to identify both of these and smush them together. So we need to find our NH4 and our OH on our polyatomic chart. So let's find our NH4 first, which is right here. So it's ammonium. So our first word's going to be ammonium. And then our OH is hydroxide. So it's going to be ammonium hydroxide. And then let's do one more example. So this one is a metal and a polyatomic. So we're just going to go back to naming like we did 17 and 18. So RB is rubidium. So I'm going to write rubidium. And then NO2, it's a polyatomic. Got to use my chart. So let me see. And NO2 is right here. It's nitrite with an ITE. So nitrite. Whoops. And that's correct. Okay. So I hope some more of these examples were helpful for you. So again, metals come first, right? And in all of these, they're either going to be a +1 or a +2 that you have to identify. And then the second part of the naming is going to be your polyatomic that you use your chart to help you identify. Okay. Now, of course, if you still need some help, let me know. But if not, I hope that this was helpful.